is question number 20 from the worksheet, which says that fx equals half x minus 2, gx equals 4 plus x minus half x squared, and the domain is, for both of them, is x is an element of real numbers. That means x can take any value on the number line. Find the points of intersection of the graphs of fx and gx. So gx is some quadratic graph. It's in minus x squared, so some upside down u, and fx is a straight line. So you need to find these 2 points of intersection, and of course algebraically. So let's equate the 2 equations and then solve them. Half x minus 2 is equals to 4 plus x minus half x squared. I'm bringing half x squared to left. Then there's half x. Then minus x is brought to the left. Minus 2 minus 4 is equals to 0. Getting half x squared minus half x minus 6 is equals to 0. I'm going to multiply both sides with 2. So x squared minus x minus 12 is equals to 0 is the quadratic equation that I'm getting. I'm going to solve this using middle term breaking. So it's going to be x squared plus 4x minus 3x minus 12 is equals to 0. X common, x plus 4 minus 3 common, x plus 4 equals 0. X minus 3, x plus 4 equals 0, x equals 3, and x equals negative 4. These are the values of x of the point of intersection, 4 and negative 3. Now you'll have to find the value of y. So you can put x back in this equation or this equation. I'm going to prefer the linear one because it's easier. So the y will be equals to 3 by 2x, sorry, half x, which is 3 by 2 minus 2. So that's going to be minus 0.5. That's the first point of intersection. Minus 3 comma, hold on, it's going to be x is 3, and hold on, I think I might have made a mistake somewhere. Yeah, big fat blunder here. This was minus, this was plus. Oops. Okay, so then this will be minus, this will be plus. Minus here, plus. So plus and minus. So we have minus here and plus here. Okay, so now this will be minus 1.5 minus 2. So minus 3.5. And the other one is 4. 4 divided by 2 is 2. 2 minus 2 is 0. So y is 0. So the points of intersection are negative 3 comma minus 3.5 and 4 comma 0. Okay. Next it says, find the set of values of x for which fx is greater than gx. Okay. So we've already substituted fx is equals to gx. Now we're going to write an inequality sign here. This is the working for 2, by the way. This will become greater than 0, greater than 0, greater than 0. Now we already know the roots, negative 3 and 4 from part 1. So from 1, we know that x comes out to be negative 3, x comes out to be 4. Now, since this is greater than 0, you write the final answer as x is greater than the bigger value, x is less than the smaller value. So these two are the answers when it's greater than 0. Okay. Next up is find an expression for fg and deduce the range of fg. All right. Okay, so for part 3, we need fg. So g goes in the function f, so half times 4 plus x minus half x squared and minus 2. Okay, this will be 2 plus half x minus 1 by 4x squared minus 2. So this is just fg is negative 1 by 4x squared plus half. And it also says find the range of fg. Okay, so what is the domain of fg? Domain of fg is going to be the domain of g, which is x is an element of real numbers. We can see that from here. Now, since it's a bit confusing that what would be the values of x, what would be the values of y if you're taking all the values of x on the number line. So the best way to find range in this case is by sketching fg. Okay, so to sketch fg, I'm going to find the values of x first. That is the x-intercepts by equating fg to 0. So by making y 0, we get the x-intercept. So multiply both sides with -4 for simplicity. So we get x squared minus 2x is equals to 0. X common, x minus 2. So we're getting x is equals to 0 and x is equals to 2. So the sketch is going to look something like this. It's going to cut at 0 and 2. And since it's negative x squared, it's going to be an upside down curve. And since there's no constant here, so the y-intercept is also 0. So the curve goes something like this. And now this is where the curve peaks. That is where x is 1. And when x is 1, this becomes -1/4, 1 squared plus half times 1. So negative quarter plus half is going to be a quarter, 1/4 or 0.25. So this is 1/4. So the maximum value this graph takes is 1/4. So the range of FG is going to be FG is less than and equals to 1/4. Okay. Next part is that hx is equals to 4 plus x minus half x squared. So it's the same as gx. Find the smallest value of k for which h has an inverse. Okay. Now again, it must be a one-to-one function. That is, it must pass the horizontal line test for uh, the function hx to have an inverse. Okay, so let's write hx again. This is part 4, which is 4 plus x minus half x squared, and x is greater than equals to k. Okay, so let's sketch this graph and see that whether it satisfies the horizontal line test at the moment. So we're going to take all values of x. So what I need you to do is just use your calculator and solve this quadratic equation. X is, A is minus 0.5, B is 1, C is 4. Just go ahead and do it, and you should get x equals 4 and y equals -2. Let me quickly check as well. Minus 0.5 and 1 and 4. Yes, we get 4 and -2. So 4 and -2. And it's an upside down graph. So it is going to be, it's negative x squared. So it's going to be an upside down view. And the y-intercept here is 4. So it cuts the y-axis at 4. Sorry, here. So the graph will go like this. It will peak and then it will fall down. It has to peak on in the first quadrant because it is a symmetrical graph. Let me do a better job with the plotting. So that's, if this is -2, then this is going to be +2 and this is going to be 4. So the graph will now clearly peak in the first quadrant because it has to peak in between 4 and -2, which is going to be at 2. No, not 2, 4 plus -2 upon 2. So that's 2/2, which is 1. So it peaks at 1. So now this is not a one-to-one function very clearly, because if you draw a horizontal line, It cuts the graph at 2 points, not 1 point. So for it to be a one-to-one function, and it says that x has to be greater than and equals to k. So let's say this is the k and x is greater than equals to k. So if you only consider this part of the graph, then it's a one-to-one function. So the smallest value that k can take is this one. So k is equals to 1.